Okay, hello and welcome to this AI certification course. This is a one credit course divided into five modules, which will involve sort of these five videos. And this is module one, yeah, the very first module. Here, we are going to look into a little bit about the mechanics of AI. Yeah, looking a little more into details of how AI actually works. Yes, how does it understand text? Okay, how does it understand meaning? Okay, now the first question that might arise in your mind is why do we even need to understand how AI works? Yeah, I mean you have all used ChatGPT. But probably some of you have used Gemini, and some of you might have used other fancier models, AI models. So why do you, as a user, need to know how the AI works? Yes. Now, of course, this is not going. This first module will not give you like a very detailed view of how AI works. It will give you a high level view. Yes, and the reason you need to know that is. In order to use AI effectively, in order to use Gemini from Google effectively, yes, you need to understand a little bit, yeah, about how it works. Yeah, the analogy that I give here is of driving cars. Yes, if you are driving a car, yes, you need to know something about the car. Yeah, at least at the basic, you need to know that is this a electric car? Is this a car that runs on gas? Yes. So some details about what you're using is useful for you to use that tool more effectively. Yes. And a very similar thing happens with, for example, cars. Yes, where you also have to, like when you go and take a driver's license. Yes, they test your knowledge about various things, including when you're taking the actual physical driving test. Yes, they test your knowledge about the car itself. Do you know how the indicator works in the car? Yeah. Do you know how to reverse the car? Yeah. So some details about how a car works is very important to know in order for you to be an effective uh, driver of the car. Yes. But also some safety critical things. Yes, like you need to understand the signals on the road. Yeah, you need to understand what a stop sign means, what a yield sign means, and so on. Yes, and only then are you given this driver's license, which is like a sort of a certificate for you to be able to drive the car. Yes, a similar thing is true for AI also. Yes, you need to understand the limitations of AI. Yes, in order to use AI effectively. Yes, you need to understand the capabilities of AI in order to use AI effectively, and that's what this whole course is about. Yes, but the first part of it will be looking at some of the sort of details of how these AI systems work. Okay, and that's what we are going to do here. So let's get started. Okay. So AI, as we talk of today, yes, is a little different from what we were doing like 10 years ago. Yes, and part of the reason is this arrival of these things called large language models. I mean, most of you have already used these things. Yes, you have used ChatGPT or Gemini or a similar tool. Yes, those are what is called as large language models. Yes, but these things have a history. Yes, they started somewhat long ago. Yeah, somewhat long ago we got calculators or sort of computers. Yeah, these things followed sort of rigid rules. Yes, you programmed them to do something, they did exactly that. Yes, deterministically. Yes. Then there was this era of machine learning, which sort of lasted for a sort of long time. Yes, this involved the computer itself. Yes, learning patterns from data. Yeah, the data could be small amount of data, it could be large amount of data. Yes, but then there was sort of a big paradigm shift around 2017. With the arrival of these transformer models and large language models. Yes. Now, these models did something that was very clever. Yeah. They understood language. Yes. That's very important. Yes. Language is a fundamental uh, uh, thing that only humans seem to understand. Yes, I can talk to you in English and you can talk to me back and we can understand each other. Yes, or some other language. Yes, doesn't have to be English. Yes, but these large language models showed an amazing capability of understanding language. Yes, and with the understanding of language, just as how humans evolved, yeah, languages evolved, and with language, people could now understand context, they could understand goals, they could reason about things. Yes, they could create new content. So this is with human evaluation. The same thing is happening with large language models. Yeah, after developing the capability of understanding language, it also somehow has a capability of understanding goals, being able to reason, understanding the context of some conversation. Yes. And that is what gives amazing capabilities to these large language models. And that's why they are very useful and important to know in the current age. Yes. Now, let's go back a little bit. Yeah, to introduce large language model, I'll go back a little bit to machine learning. Yeah, this is what sort of has been there for quite a few decades. Yes, what happens in machine learning? Yes, different from traditional coding. Yeah, traditional coding are sort of rigid. Yeah, they use sort of this if-then rules. Yeah, like they are rule-based thing. Yeah, if something happens, then do something or output something and so on. Okay. Machine learning, on the other hand, is able to identify patterns in massive data sets. Yeah? The data set sometimes can be massive, or sometimes this doesn't have to be massive. Yeah? It could be small data set also. Okay. An example of that is that if you show a machine learning tool, if you train it by showing millions of chairs, okay, millions of images of chairs and cats and dogs, okay, then um, then the machine learning tool will be able to recognize a cat. Okay, it will be able to not just recognize a cat, it will also be able to recognize a chair. Yes, because you showed like a million images of chairs. Yes, and it will also be able to recognize dogs. Yes, because you showed a million images of dogs. Yes. So that's why machine learning was also is also pretty successful. Yes, the way a machine learning thing works is that there is initially a vast amount of training input that goes into the machine learning model. This is that millions of data points. Yeah, millions of data points. Yes, so a data point could be an image. Yeah, so as in this example, it's an image. Yes, it could be other things also. Yeah, as we will look in the future slides, there might be other things also you can train a machine learning model on. There are millions of data points, but there's also like what is the expected output from the machine learning tool for the data point. Yeah, so if I give a cat image as an input, the expected output of the um, machine learning tool should be that this is a cat image. Yeah, something like that. Yes. And so there is a training process which happens taking these millions of data points as input, and then there is some sort of pattern learning that goes on. Okay, which is a complicated process. That's a detail we are not going into in this course. But once you have that, yes, once you have that, what you get as an output is what is called as a machine learning model. Yeah, this is a trained model. It's already trained. Okay. Now you can use it. How can you use it? Yes, so that's what I'll show on the next slide. Yeah, you can give an input image. For example, I'm giving an input image here as a cat, and this goes into this machine learning model. Yeah, these things are also called classifiers. Okay, because what they do is they output. So they are trained on a number of classes. In this case, suppose four classes: cats, dogs, cars, and trees. Yeah, they were trained on four types of images: cats, dogs, cars, and trees. So millions of images of these types. But once they are trained, I can give it one input, and it would output to me. which category of input this is. Yes. So this is an input which is of course a cat. Yeah, you and me can easily tell that this is a cat. Yes. But a machine learning model, this is a completely automated system sitting on a computer, can also look at this image and tell us that this was a cat. Yeah. Now, it doesn't exactly tell you this is a cat. Yeah. What it gives you are probabilities. Yes. So it tells you that this can be a cat, okay, with say this is around 92% probability. Yeah. So it tells you that this is a cat, but the probability here is around 92%. Yes. It could be a dog, maybe with 5% probability, car with 2% probability, and tree with 1% probability. Yes. Of course, this will sum up to 100. Yes. So it doesn't exactly tell you that this is a cat, but it tells you that very likely this is a cat, yeah, with more than 92% confidence. Yeah. So these are what machine learning models do. Yeah. They have been doing this for last few decades. Yeah. This is not a very new thing. Yes. But the main thing that I want to get across here is that on any given input, like an image, a machine learning or model will output probabilities over the different classes. Yes, the classes being the classes that it has been trained on. Yes, so in this example, it was trained on these four classes: yeah, cats, dog, car, and tree. Yeah. Okay, so that's what a machine trained machine learning model can do. Yeah. Now, from this example, you might feel that okay, these machine learning models can only take images as input, but that's not completely right. Yeah, you can have different machine learning model. Yeah, this is a different machine learning model. The picture looks the same. Don't go by that. Okay, but the model is different because this model can take a whole text as input. Yeah, for a full sentence. This is the input text. Okay, this is a full sentence. It's a review of a movie. Yeah. If you see the movie review here is quite negative. Yes. So this is a model that was trained to do a sentiment analysis, which is another of these classification tasks. So what is sentiment analysis? So it takes some text like a movie review as input and outputs the sentiment uh, present in that text. Yes. So clearly the sentiment here is negative. Yes. So you can have either positive sentiment or negative sentiment. Okay. And this model outputs that, okay, with like very likely this is a negative sentiment input. Yeah. With 95% chance, this is a a negative sentiment input, and maybe with about 5% chance this is a positive sentiment input. Okay. But the model is quite correct. Yeah, because it is saying that very likely with 95% chance it is a input that has a negative sentiment. Okay. So as you can see, you can build a classifier for different kinds of inputs. Yeah, it could be images, it could be text, it could be some other thing also. Yes. So this is all still very classical. This is classic machine learning. Yes. Now we come to large language models. Yes. So large language models are these things here, like ChatGPT or Gemini that you interface with. Yes. What they do is they are also a predictor. Yes, meaning they also predict something. What do they predict? They predict the next token. Yeah, what do you think of a token? I mean, for now you can think of a token as the next word. Yeah, but I will come to this point again. Yes. So you can think of a token as a word. Yes. So if you tell, for example, a large language model, the capital of New Jersey is, and stop. Yes. Then it will output the next word. Yeah, the next word uh, it will output should be Trenton. Yeah, we all know the answer is Trenton. Yes, but it is also a model that outputs probabilities over the different possible outputs. Yes, just like your machine learning model, since see it was outputting probabilities over the different possibilities. So for the image, it was outputting probabilities for it being a cat, for a dog, car, tree. And because this was a good model, it output a very high probability for a cat input. Yeah, that's fine. Okay. This large language model is also very good. It will output a high probability over the correct answer, which is Trenton, 98% probability. For some other possibilities like Newark or New Brunswick, the possibilities are much lower. Yes. And of course, there are many other words. Yeah, in the English language, these are not the only other words. Yeah, there are a number of other words. Yes, LLMs will output a probability for every word actually. Yeah, in the English language. Yes, and those probabilities might be really very small, 0.001 or so on. Yeah, but it will output a probability for every possible next word. Yes. But one of these words will very likely have a high probability. Yeah. And this is the word that is very likely sort of the correct completion of the sentence. The correct completion of the sentence is Trenton. Yes. And therefore, Trenton should have high probability if this LLM is any good. Yeah. So LLM, of course, is an acronym. Yes. LLM is an acronym for large language models. Yes. So, but nonetheless, this probability is this is 98%. Yeah, it is not 100%. Yes. So so that's why AI, yeah, or specifically LLMs is sort of a sophisticated probability engine. Yeah, it outputs the next word, it predicts the next word. Yes, uh, and it does it by outputting probabilities of what the next word could be. Yes, with there will be a very high probability on the correct word. Yes, but uh, there will still be some non-zero probability over the other words. Yes, that's why it is important to understand that AI or LLMs are probabilistic. Yes. Okay, so that's a very critical point to understand about LLMs and the behavior of LLMs. Yes. Okay, why am I saying or emphasizing this that much? Yes, because you see the probability of the word Trenton here is 98%. It's not 100%. Yes. What does that mean? What that means is if you input this text, the capital of New Jersey is into LLM. Yes, if you do that 100 times, yes, 98 times you will get the right answer. But two times you might get some answer which is not correct. Yeah, a different answer. Yes. So this is getting to the point that LLMs are probabilistic. Yeah. Meaning anytime you ask it a question, it can give you an answer, but the next time you ask it, it can give you a different answer. Yes. So you should be very well aware of this behavior of LLMs. Okay. Okay, so this was only when sort of we are looking at the next word, yes. But LLMs don't just generate one word, yeah. They generate a sequence of words, like a sentence, yeah, or a paragraph, yes. How do LLMs or large language models do that? Yes. So for that, we need to understand what we mean by tokens. Yes. So here I said that, okay, you can approximately, and that's always correct, you can approximately think of a token as a word, oh yeah, like Trenton or Newark. Yeah. New Brunswick is actually two tokens, two words. Yes. But token is actually even more fine-grained than words. Yes. So your LLM or AI, I'll call them LLM or AI. I'll switch between these two things. Okay. It doesn't read letters. Okay. It chops the words into tokens. Yes. Which is what it understands. Okay. For example, it might break the word Rutgers into Rut and Gers. Okay, and each such token will be uniquely identified. Okay, and everything that you give it, even if you give it a math thing, yeah, like if you ask it to do 1 plus 2, yeah, uh, LLMs do not understand digits. Yeah, they will sort of they will read this as text. Okay, 1 plus 2, yes, it can effectively compute this. Yes, that's fine. Okay, but that how it does that is something we are not, again, it's a level of detail we will not go into this course. Okay. Okay, so this is what is tokens. I don't want you to get the impression that token corresponds to word. It always does not. Yeah, as this example tells you here. Yes, and with that, let's look at how an LLM generates uh, a sequence of words, because it is not just generating one next word. Yeah, it as you have seen with ChatGPT, you ask it a question, it gives you a whole sentence or a paragraph as answer. Okay, so how does it do that? So suppose you do this. Yeah, suppose the LLM, you give it an input, the quick brown fox jumps. Okay, this is a very common sentence. Okay, you can Google it and see what the completion will be. Yes, but the next word is over. Yeah, so when you give this as an input to the LLM, yeah, the quick brown fox jumps. Okay, the LLM will very likely output over. Yeah, it's very likely. I'm again saying very likely. It's not guaranteed with 100% probability, but very likely it will output the word over. Yes. Once it outputs the word over, what happens is that that word over is sort of fed back as input now to the LLM itself. Yes. And now the whole input has become the quick brown fox jumps over. Yes. So what was the output earlier, over, which is again highlighted here in green, is now considered part of the input. Yes. And with that, the next word that will be generated will be the. Yeah. The quick brown fox jumps over the. Yes. So this is the next word. Again, now this next word becomes part of the input. Yeah. And and now the input is the quick brown fox jumps over the. So then the LLM will be asked to produce the next word. Okay, and the next word is lazy. Yes, and this will continue. Yes, so this will continue. But what you will see, do not see this one word by one word generation. Yeah, whenever you ask something to Gemini, you don't see this single word by single word. Yeah, you directly see the full output. Yeah, you just see that this is the input you gave and this is the output that you obtained. Okay, so but behind the scenes what is happening is one word is being generated at a time. That word sort of becomes part of the input, and based on that the next word is generated. Okay, so that's why and this phenomena of doing it this way is called generating auto regressively. Yeah. uh, So that is how LLMs generate autoregressively. Yes. Okay. So that's all good. Yes. Uh, Again, a fact that I will stress here: even when generating autoregressively, LLMs are probabilistic. Yes, meaning that suppose you give an input, the sun rises in the. Yeah. And the LLM's possible outputs, there are many of them. Yes, this is a probability over all possible words. Okay. But maybe the highest likely answer would be east. Yeah, with a 0.4%. This is not 0.4%, 0.4 probability. Yeah, 40% chance. Okay, and morning has a 30% chance and sky has 17% chance and something. And maybe in the instance that you asked, out of these words with a high probability, maybe morning is the one that got sampled. Okay, and therefore you see the answer, the sun rises in the morning. Yeah, that's fine. Okay, but if you ask the same question again, the sun rises in the. Okay, if you ask the same question again, yes, there is the LLM, and it will have a similar kind of probability like this one. Yeah, is not similar, exactly the same, because the input is exactly the same. Yeah, so east is 0.4% probability, morning is 0.3% probability, and so on. Yeah, and maybe the second time you ask, then this is the one that gets chosen. Yeah, 40% chance. Yes, It is not necessary that always the one with the highest probability will get chosen. As you can see in this example, morning was chosen. Yeah, it has a 30% chance of being chosen, but 30% is not a small number. Yeah, so it can still get chosen. Even though east has a higher chance of getting chosen, like 40%, it's not guaranteed that east will be chosen. Yeah, but maybe if you call it a second time, maybe east will be chosen. Yeah, and in that case, the response, the completion that the LLM will do is that the sun rises in the east. Yeah, that's that's how it will work. Yeah. So it's very important to stress the fact that LLMs are probabilistic. Yeah. Here I'm showing different outputs on just one word. Yes. But it doesn't have to be one word. Yeah. Maybe if there is a continuation after this, if there is words generated after this, yes, they will also be different. Yes. Because this one was morning. Now you remember this morning. Now this whole thing has become sort of the input to generate the next word. Yes. And because the input is different, this is morning versus this is east. Yes. So whatever is generated after this will depend on this morning and this east. Yes. Maybe after this, the LLM will start talking about morning and evening and so on. Or maybe, and in the second case, after east, it might start talking about the directions. Yeah. West, north, and so on. Okay. So remember that LLM's answer can be different for exactly the same input that you give. Yes. The answers could be different. Yeah. And that's a very critical point about LLMs. Okay. Okay, so this is some very basic introduction to how large language models work. Yeah, they are a predictor. They predict the next word or the token if you want to be exactly correct. Yes, and they do this auto-regressively. The next word generated sort of becomes part of the input, and then based on that, the next word is generated, and so on. Okay. Okay. So that's a basic introduction to how LLMs work. Yeah. Now, of course, there are a variety of different LLMs out there. Some of you have probably seen this. Okay. This is a sort of a little old chart from February 2025 showing what are the sort of release plans of different LLMs. So OpenAI, as you know, has its GPT series of models. And right now we are running on GPT 5.2. Okay, that's been already released. XAI has this Grok series of models. Okay, Anthropic has its own Claude series of models and some reasoning models. Meta, which is like sort of Facebook, yeah, has its Llama series of models. Google has Gemini models. And in Rutgers and in the business school, you have access to Gemini, yes. So that's the tool that we are going to work with in this whole course, yes. That's the tool that we are going to show you how it works and so on, okay. Of course, Microsoft has its own Series 5. Baidu has Ernie, and there's DeepSeek, and so on from a variety of other providers. Yes. Now, of course, it is simply not possible to go through all the different tools here. We are going to focus on Gemini and its capabilities. Yes, but in order to understand again the capabilities, what it means, we are still not done with how LLMs work. Yeah, so I told you a little bit about how LLMs work, but we have to go into more details of how LLMs work. Yes. Now, one thing before going there is these are sort of what are called as the big models. Yeah, like the frontier models. Yes, but there are a slew of other models, yeah, like a whole like a zoo of models. Yes, here I have put in a table which shows some of these things, uh, showing you like some models. So there are some models which are called like frontier or foundation models, if I might. Okay, these are the really big models here. This includes things like GPT, Claude from Anthropic, Gemini from Google, and so on. Okay. Then there are some models that are also sort of big, yes, but focused on reasoning, focused on doing logic, math, and coding problems, yes. Uh, and there are some of these. There's versions from OpenAI, the O series of models, and there's DeepSeek, okay. And then, of course, there's Llama from Meta, which is open source. But there are some models very specialized for some domains. Yes. So there are these models specialized for the medical domain. Yeah. There are models specialized for coding. Yeah. So the Qwen 3 coding software is specialized for coding. Yes. And there are models specialized for like law and finance and so on. Okay. So, and there's a bunch of these things. Okay, I have not listed everything here. It's simply not possible. Yes. But in this course, we are sort of going to focus on the frontier models. Yes. In Rutgers, we have access to Gemini. That's what we are going to look at in details. Okay. And we will see that Gemini itself provides a lot of tools for specialized tasks. Okay. So sometimes you might not even need some of these specialized tools. Okay. You can do things with Gemini without having access to these specialized models. Yes. And that's why these models are sort of the most powerful things out there. Okay. Okay. So let me talk a little bit about LLM training. Yes. Of course, there's a lot more than what I'm going to say here. Yes. But I first want to give you a flavor of how large language models are trained. Okay. They're not trained in a very simple way like the machine learning models. And what that means, what that means is these LLMs don't have the standard pipeline of training that a standard machine learning model has. And this pipeline of training can also tell you a little bit about how the LLM will work. Yes. And that's why I'm actually going to go through the pipeline. Yes. So the pipeline here is sort of roughly divided into 4 stages. So the first stage is called pre-training. Yeah. This is the stage where it is trained on huge amounts of data. Okay, huge amount of data. And I will come to those numbers, how much data and so on. Okay. The second stage is what is called as instruction fine tuning. This is where the LLM is trained to be able to answer questions. Yeah. So it becomes a question answering system. Yeah. Where if you ask it a question, it will give you a reasonable response to the question and not just some response to the question. Yeah. It will give you a fact, try to give you uh, as good as a response as possible. Okay. Then the final thing, not the final thing, the second last thing is preference fine tuning. Yes. So preference fine tuning is also called as alignment. This is where the large language model is trained to answer, to output answers that are preferred by a actual human user. Yeah. So these are answers that humans like compared to other answers. What other answers? So again, going back to how LLMs work, remember for the same question, they can give you multiple answers. Yeah, they are probabilistic. Yes. But some of these answers might be preferred by humans. Yes. So this stage 3 is where the LLM is trained to increase the probability or the chances of outputting such answers that are preferred by the humans. Okay. And the last very recent thing is reasoning fine tuning. Yeah. This is where, when asked questions which require logical reasoning, this could be, for example, math questions, coding questions, and so on. Okay. LLM will do some amount of reasoning. Yeah. About the question itself. Yes. How to do that reasoning, etc., is what this stage 4 enables the LLM to do. Okay. The stage 4 is where the LLM is explicitly trained to be able to reason more accurately, more logically about questions that have been asked to it. Okay. And these are the questions that require reasoning. Yeah. For example, math questions or coding questions and so on. Now we'll look at each of these things in a little more detail. Yeah. So let's do that. Yes. So this is the first stage, pre-training. Yes. So in pre-training, this is where the LLM simply learns to continue the text. Okay. This is the examples that I was giving. Yeah, you give it a, sentence like the capital of New Jersey is, and it will learn to complete the text. Okay. Or if you give it example, the capital of New Jersey, and stop there, then it should complete it as is Trenton. Yes. So this is what pre-training does. Pre-training is done on huge amount of text data. Okay, huge amounts. Okay, and so the data is used to make the untrained LLM into a pre-trained LLM. Yes. So here the example being given is DeepSeek, but the same thing happens for GPT or Gemini or any such model. Yeah. But if you see what happens here, like if you do this, yeah, after you're done with pre-training, if the user asks a question, what is an LLM? Yes, the response will be not that good. Yeah, because it you asked it a question, it just continued to fill in the text. It asked you further questions. Yeah, it didn't really give you an answer. Yeah, it just asked more questions to you. Yeah. So pre-training is not enough. Yeah, you actually, when you talk to ChatGPT or Gemini, you're never seeing a pre-trained LLM. Yeah, what you might be seeing is a LLM after fine tuning. So this is called instruction fine tuning. Yes. So here you train it with a lot of instruction response pairs. What are these? These are things like questions followed by answers. Yes. So you train it on a lot of questions and answer pairs. Yes. So what is one example of this? So one example of question could be what uh, is a car? Okay. So this is your question. And the answer for this could be is, okay, car helps you go places. Yeah. This is not a very good answer, but that's coming to my mind right now. Okay. Uh, so, so such question and answer pairs are what is given to the LLM. Okay. Uh, and the way it is given is this is given as an input, and the LLM is fine tuned or trained to output this. Yeah. So it's trained now to output good answers. Yeah. So good answers which are present in this instruction response pairs. Yeah. This is a big data set also. Yes. And then this pre-trained LLM becomes an instruction fine-tuned LLM. Yeah. And this is the one that will be good at answering questions. Yes. Even though you did not train it on some of the questions, maybe you did not train it on a question called what is a LLM? Yes. But still, even if you trained it on different question answer thing, the whole LLM becomes good at answering questions, even if that question was not present in this training data set. Yeah, that's the magic of machine learning or LLMs. Yes, and after you do this, you ask if the user asks a question, what is a LLM? Then the answer will be quite reasonable. An LLM is a type of machine learning model that trained on so on. Okay, and some large amount of text here will be the response of the fine-tuned LLM. Quite a reasonable response to the question. Yeah, it's not asking a question in as a response to your question. Yes, so that's called fine-tuning. Yeah, all the large models that you encounter, Gemini, DeepSeek, GPT, Claude, have been fine-tuned. Okay. You almost never encounter a model that is only pre-trained. Yes, unless you are doing research. Okay, but the models that the general production level models that you encounter have all been fine-tuned. Okay. And another thing that the general models that you encountered have been have gone through is this process of alignment or preference fine tuning. Yes. So, what is preference? Yes. So, some of you who use GPT would have seen this. Yes. Is sometimes what GPT does is if you ask it a question, yes, like how can I improve my public speaking skills? Yeah, this is a question asked to GPT. Okay, And GPT, as I said, it's a probabilistic system, yes. So it will output two responses, yes, or more the responses, four responses, five responses, and so on, yes. But it only shows you one response, yeah. That response which has the highest likelihood, yeah, which is more likely. Okay. But sometimes, very often, you will see GPT will give you two options, yeah, response A and response B. Which one do you prefer? Yes. And then you might say, okay, I prefer this response, yeah, and not this one. Yes. Um, because you see, as a human, yeah, both these responses are somewhat factual. Yes, improving public speaking is impossible for some people. Just accept that not everyone is good at it. Yeah, this is response B. Okay, it's somewhat factual. Yes, but this is not a response you would like. Yeah, this is not sort of what you were in the first place. This was not the intent of your asking the question. Yes. So response A, which says something like to improve public speaking, start by practicing in front of a mirror and recording yourself, focus on speaking clearly and confidently. This is a much more helpful and useful response. Yes. And therefore, this is very likely going to be preferred by whoever the user is. Yes. And then the critical part of such things is such uh, taking into account the human preference, yes, you can take this sort of data, yes, where the human has clearly indicated that this is preferred and this is not, okay. You can take that data and you can update your model. Yeah, you can update your model uh, based on such preference data. Yeah. So this was just example of one preference data. Yeah. One prompt and two responses and the human telling which response is preferred. But you can gather millions of such data points. Yeah. Millions of such prompts. Okay. And two responses to it. Okay. And the human telling us which response is better. Yeah. So if you have such a data set, from that data set, you can glean the human preference, yes, and you can use that to update the model so that the model outputs such responses like response A more than response B. Okay, even though response B has a certain probability, what will happen is the probability of outputting response B will go down after the model is updated, and the probability of outputting response A will go up here. So the model will be trained to output response A with more likelihood and response B with less likelihood. Okay. So this is the notion of preference. Yes. This is what happens in this step called either alignment. It's also called alignment. Sometimes it's called preference fine tuning. Yeah. So here again, yeah, you have this kind of a data set, okay, where in response to a query, you have some preferred response, response one, and some response that is not preferred, okay. And you don't have just one such a query and response pair, but you have maybe millions of such queries and response pair. Yes, of course, forming this requires you to have a human in the loop. This human is very important. Yeah, this is the human who's saying whether the response is preferred or not. Okay, and so you get this instruction user labeled instruction response pairs, and you use that to update the model. The model is updated with a technique called RLHF or DPO. We are not going to go do a deep dive into techniques, okay? But all I'm saying is the LLM itself is trained or updated uh, to uh, to increase the likelihood of outputting such preferred responses, okay, and not the responses that are not preferred. Okay, now this is a point where I will also say something that's typically not stated in the technical textbooks. Yes, so preferred responses, what does it mean for a response to be preferred? It means that this human, okay, likes the response. Yeah, likes the response. Yes, it does not mean that the response is correct or even factual. Yeah, maybe you as a human like a response of the LLM even when the LLM is lying. Yeah, that happens. Yes, So this alignment step, yeah, this makes the LLM try to please humans. Okay. Now, this is fine. Okay. In some cases, this is fine, as you saw in this example. Yeah. In this case, it's fine. Yes. But in some cases, this is dangerous. Yes. Because making the LLM please a human means that uh, the LLM could lie. Okay. So one way of pleasing humans is to lie to them. Yeah, I mean you have probably experienced this somewhere. Yes, and by this alignment step, by making the LLMs try to please humans, yeah, LLMs sort of lose the LLMs might lose the ability, yeah, or go away from the ability of generating factual content. Yeah, this is the place where LLMs can do what is called as hallucination. Yeah, so you might have heard of this. We will again come to this later. Is that it might cook up facts, okay, just plain wrong things, yes, that make you happy, yes, but are not correct, yes. So this thing is still there is a lot of research and those things going on these aspects, but the alignment aspect, by trying to please humans, it makes LLM a little vulnerable to either hallucinate or simply lie. Yeah. So that's one reason why you should not never rely on completely on things that are output by the LLM. And this is something I will come to later on. Yes, later on I'll re-emphasize this fact again a lot. Okay. Okay, so so this is alignment. Yes. Now I want to say one thing is this is not completely a bad thing. Yeah. Yes, this makes LLM lies and hallucinate and so on. Okay, but it also makes LLM very useful, as we saw in this example. Yeah. Without this alignment, a lot of LLM output could simply be bad from human perspective. Okay. Okay. And the last step is called reasoning. Yes. Now, I'm going to show a sort of a classic example of what is called as chain of thought reasoning. Yes. So these LLMs, yes, when they work, you can give it an input. Yes. So you can also in the input give an example of a problem that a type of problem that you want the LLM to solve. Yes. So let's look at the input here. This is on the left side. This is your standard way of prompting. You give it a question and you give it an example answer. Yeah. So the question is simple. The Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? Okay. So you can do this 3 times 2, 6 plus 5, 11. Okay. Here you give it the answer 11. You give it the answer 11 without any reasoning, meaning you just give the answer. Yeah. You do not tell how you should obtain the answer and so on. Okay. So this is an example. This whole thing is the input to the LLM. Yes. But oftentimes, if you give an example uh, to the LLM performs better. Yeah. If you didn't give this example, if you directly ask this question, the LLM would probably even not output the right thing at all. Yes. But in this case also, you give this example, you give an answer, that's fine. But if you ask the question, that the main question that you really want the LLM to answer is the cafeteria has 23 apples. If you use 20 of them to make lunch and bought 6 more, how many apples do they have? Yes. It would give something like answer is 27. Yes. Now this might not work with the current LLMs. Yeah. This is based on a slightly few years old. Yeah. As the LLM models get updated, they become better and better. Yes. But this answer is clearly wrong. Yes. But the same question, the same if you ask with a sort of answer, with example answer that is based on some amount of reasoning, then the LLM surprisingly does reasoning on its own and becomes a little better. Yeah. So what is this thing on the right? So these things are sort of called as chain of thought prompting. Yes. What does that mean? So what that means is in your question itself, the whole of input. Yeah. This whole box is your input. Yes. You the first example that you're giving, you give a question. Yes. This is a question is exactly the same as on the left side. Yes. But the answer that you're giving, you give as the example, has reasoning steps inside of it. Here says Roger started with 5 balls, 2 cans of 3 balls each is a total of 6 tennis balls. 5 plus 6 equal to 11. So the answer is 11. Yeah. This blue part here is the reasoning example that you gave. Yeah. You told it that you can reason in this way. Yes. And then you ask your main question. Yes. And because you gave this as your reasoning example, yes, the LLM, when continuing this text or like when responding to your answer, uh, has this whole input in its context, yeah, as whatever went as input to the LLM, yes. And in the context of the LLM, it sees these reasoning steps and therefore it also tries to do reasoning in a similar manner applied to this question, of course, yes. And therefore, you see now the model output also has reasoning steps. Yeah, the cafeteria has 23 apples. They use 20 to make lunch. So now they have 23 minus 23. They bought 6 more. So now they have 3 plus 6 equal to 9. The answer is 9. And this is the correct answer. Yeah. So, so these are, this example really shows to you that large language models are capable of reasoning. Okay. So here, this is an example where the large language model has not even been trained to do reasoning, yes, but it is still capable of reasoning if you ask your questions with some examples inbuilt into it, which have reasoning based answers, yes. So if you prompt the LLM with such inputs which have reasoning based answers, the LLM is also sort of pushed or nudged to do reasoning on its own and output reasoning based answer based on which the answer is very likely to be correct. Okay. So this type of prompting, yeah. So what does prompt mean here? Yeah. So when you give an input to the LLM, when you ask a question, this, for example, this input, this whole thing is called one prompt. Yes. Chain of thought prompting is where your prompt in has some examples of some reasoning. Yeah. And then a final question. And when the LLM responds to your prompt, then it responds uh, itself with some reasoning steps, yeah, because your prompt itself involved reasoning steps, yeah. This is what is called as chain of thought prompting. Yes. Now people have taken this further, yeah. This was discovered a few years ago, yes, but people took this further. Is the in all of this, yeah, the LLM itself is not being trained. Yeah, this is just some input to the LLM and the LLM produced output. Yeah, which is showing that the LLM has inherently some capability of reasoning. Yes, you have to poke it. You have to poke it by giving it some reasoning example so that it can output an answer with reasoning inbuilt into it. Yes. Uh, but people took this further and say that why not train the LLM to reason every time? Yeah, meaning even for such an input, yeah, why not train the LLM to reason about this question instead of just outputting something like this? Yes, that step is what is called as the reasoning step. This is one of the steps in training. This, of course, has happened only for over the last previous 3 or 4 years. So this is called as reasoning fine tuning. Yes. So what you do here is you also build a data set. Okay. Some sort of a reasoning task like a question, and with the answer that is uh, where there are reasoning steps involved. Yes, you ask the LLM to do this to answer the question. Okay, the LLM would answer the question. You ask the LLM to do a reasoning driven response. And based on how good or bad it reasons, there are some ways of doing that. I'm not going to details of that. You calculate some reward. And then reward is basically telling whether the LLM's reasoning was good or bad. Yeah. So if the LLM's reasoning was good, it will get a high reward. If not, it will get a low reward. And based on that, the LLM itself is trained. Yeah. Meaning the LLM is updated. Yeah. And and it's updated to maximize the reward, meaning that it is updated to choose a better reasoning wherever possible. Yes. So after this step, the LLM will be able to reason things itself. Okay. Without you really having to do this. Okay. You don't really need to do this. Okay. The LLM will figure out that will do the reasoning steps itself without you having to like sort of explicitly prompt it. Yes. Now that doesn't mean that explicitly prompting it like this is bad. Yeah, you can still explicitly prompt it. Yes, but if the LLM has been trained for reasoning, it will do it automatically on its own without you having to do this chain of thought prompting and so on. Okay. So that's the reasoning part of training LLMs. Okay. So these were the four stages. Yeah, this is the last stage. Yes. Now, there's a few aspects about these different stages that I will want to tell you. Yes. So this is pre-training at the very first stage. Okay. What is the data used here? This is sort of all for the large models. This is really almost all the text on the internet. Yeah. All web pages, books, Wikipedia, code, public documents, all you can call it a sort of a summary of all of human knowledge. Okay. How much data? Yeah, approximately 1 to 10 trillion tokens. If you think of tokens as a word, it's like 10 trillion words. Okay. Of course, this is the largest stage. Yeah? This is the amount of data being used to train the model. Okay. There's no human involvement in training these models. Yes. And as I had told earlier, the training objective here is to just predict the next word. Yeah. Predicting next word is the training objective. But okay, this is not enough. As we have seen earlier, we need to do supervised fine tuning, or earlier we were calling it instruction fine tuning. There are different names used for it. Okay. But instruction fine tuning or supervised fine tuning is where you have these instruction response question answer pairs. And this amount of data is much smaller. The number of words in this amount of data would be like 10 million or something. Human involvement is high. Yes, high because you as a human are providing these answers to questions. Yes. So that's why the human involvement here is high. But after this, the training is done. The large language model can follow instructions, meaning you ask it a question, it can give you a good answer. Yes. And it can give helpful answers. Okay. Next stage is what is called as preference or alignment training. This is something we already looked at. Here you have ranked responses from humans. Okay, so A versus response A, response B, which one is preferred. This stage can also involve some sort of safety tuning, yeah, where for some questions, like for example, how to make a bomb, okay, uh, the LLM's response should be, I cannot tell you that, yeah, that should be the response. Or but the LLM has knowledge about how to make the bomb. Why? Because it has been trained on all this data, all human knowledge, yes. But for a safe LLM, its response should be, I cannot tell you that, yes. So some of that safety tuning is also done in this stage. Yeah. How it is done, again, I'm not going to go into details of that. But this such response pairs would be like roughly of the order of using 1 million words. Okay, human involvement is very high because you need human involvement to do this ranking and choose the prompts and so on. Okay, this gives you responses that are better from human perspective. safer, meaning you don't get a valid response to how to make a bomb. You get a response like, I do not know. Okay. Or rather, I cannot tell you that. Okay. So, and it will learn how to refuse or redirect, yes, whenever required. Yeah, like I cannot tell you how to make a bomb. Yeah, that's a refusal response. Yes. So this alignment step is less expensive because it involves fewer tokens, but the human involvement is very high. Yeah. The reasoning step, yeah, this is where you give step-by-step solutions of either a math problem, coding problem, things like that. Again, involving data roughly of the order of 1 million words or tokens, yeah. And the human involvement is high, but not as high as in preference alignment, okay. And the output of this, it improves multi-step reasoning and reliability of the model. Okay. And of course, there is post-deployment feedback that goes on. So this is where when you are using ChatGPT, ChatGPT uses your data, yes, to retrain the model and so on. Okay, whatever questions you have been asking, okay, and responses you have been providing or getting. Okay, so this is a continuous loop, okay, which is ongoing all the time. Yeah. So till here are the four stages. After this is sort of a continuous loop that runs occasionally. Okay. Okay. So this is showing you some examples of how much data and so on are involved. Yes. But I also want to give you an idea of how much energy is involved in training these models. Yeah. So in pre-training the model, yeah, you need something called GPUs, which are some sort of a chip, but you need large GPUs, thousands of them, yes. And the amount of energy you might consume is like of the order of 100 gigawatt hours, yeah. So just to give you an example, I think the whole of Rutgers University would probably use this much energy in 3 months, okay. So the amount of energy required here to train one model is enormous. Yeah, it's almost the size of the energy usage of a medium-sized town for months. Okay, so this is not something that you and I can train on a laptop. Yeah, it's simply not possible. Yes, this is something only which large companies or government can do. Yeah, and that's why you see some of the frontier models, the big ones, are owned by Google or OpenAI, which have a lot of money. Okay. Supervised fine tuning requires less data. Yeah, still 1 gigawatt. It's the R. It's not a small amount of data. It's not a small amount of energy. It's still substantial energy. Yes. Some of these alignment things require even less energy. Yes, but they involve a lot of human involvement. Yeah, you need to gather a lot of data from humans. Yes. So while the energy usage is maybe not that much, the human involvement is a lot. You need to do a big survey with many humans. Yes. Reasoning focused again doesn't involve that much energy. Yes. And of course, so this is the four stages. After this, some companies do this. They sort of evaluate the model, do some red teaming attacks on it. Yeah. Just to see if the model is performing as expected. Yes. And then the final stage is sort of inference. So inference is when the model is actually deployed. Yeah. So, and then you are asking questions, it provides responses. There's no training in inference. Yeah. It's just the model deployed. You ask questions, it responds. This of course depends with the how much energy usage depends on the number of users. Yes. And as you might have heard in the news recently, data centers are popping up all over the US, yes, primarily to do inference, yeah, because the number of users is going very, very high. Yeah, many people are using these large language models, and therefore, even the inference stage, no training at all, yes, is also taking up a lot of energy, which has resulted in yeah, electricity prices going up in a lot of states. Okay. So this is roughly giving you an idea of the energy footprint of a large language model. And that's why you see there are not that many models that are really big, large, yes, because you cannot really do this pre-training very often. This is not a small effort, okay? Okay, so that's uh, some things about the internals of the large language models that we talked about, okay? Now I will, before going to a demo, yeah, we'll do a demo of Gemini. But before going there, uh, I want to tell you a few things about prompting. Yeah, prompting is so what is a prompt? Again, I'll recall. Prompt is something that you as a user give to the large language model. Yeah, you ask a question. What is an Excel file? Yeah, that's a prompt. Okay. Uh, in order for the LLM to be helpful to give you back useful responses, prompting effectively is super important. Yes. Uh, you might have heard of this term garbage in, garbage out. Yeah, this is used typically for machine learning. What it means, if the data on which you're training is garbage, is bad, yeah, is noisy, yeah, it's not, it doesn't have the right information, then the machine learning model you'll build will be bad. Yeah, but this is also true for large language models. Yeah, what it means here, what garbage in means, yeah, garbage in really means your prompt. Yes, if your prompt is imprecise, yeah, what does garbage mean here? It means imprecise. Yeah, if your prompt is not precise, yeah, or if your prompt is vague, yes, or it has mistakes, yes, you wanted to ask something else, you want ask something else, yes, uh, it has too many spelling mistakes. Few, a little bit of spelling mistakes is okay, yes, but too many spelling mistakes, this is what I call as garbage in for LLMs. Yeah, for LLMs, what is in is the prompt. Yeah, the prompt is what you give as input. Yes, if there are these things in your prompt will your output will not be good. Yeah, so that's one thing. Yeah, that's for garbage. Yeah, but even if your prompt is not, doesn't have these kind of problems, yeah, it still needs to be structured. Okay, you have to be extremely precise. Yeah, you have to be, you cannot be vague. Yes, plus another thing that's very important is iteration. Okay, LLMs might not give you the best response in the very first question that you ask. Yeah, then you have to sort of iterate with the LLM. Yeah, you have to ask further questions or further clarify, further ask it to improve things. Okay, so these two things are super important to be able to get good answers or good performance from the LLM. Yeah. We will look at prompting a lot in the next module, yes, where we will go through a number of different patterns of prompting, yes. But this sentence here is applicable to everything, every pattern that we go through in the next module, okay. And keep this in mind, you are talking to an LLM. LLM is not your friend. Yeah, LLM is not a person. Yeah, it doesn't understand your intent or things that you have not said. You have to say everything explicitly. Okay, LLM is not an oracle. Yeah, it doesn't know your feelings. It doesn't know anything like that. Yes, so again, you have to be explicit. Yes, you should not even think of LLM as some sort of thinker. Yeah, or even a calculator. Yes, so this is one place where people gets many things wrong. Yeah, if you ask LLM simple questions, like I have a portfolio of $100,000, and then I got a profit of 10%, and then after that I had a loss of 10%, and so on. You give it a sequence of complicated calculations, it will not be able to do it correctly. Okay, do not use your LLM as a calculator. It is not. Okay. Uh, but then what is LLM? Yeah, it's a good predictor. Yeah. It is a pattern learner. It has learned a lot of pattern from a lot of data on the internet. Okay. Uh, it can generate helpful responses. Yeah, that it can do. Okay. And it is trained on lots of data, meaning it has a lot of memory inside of the model itself. Yes. You can ask it a question about taxes. You can ask it a question about marketing. You can ask it a question about coding. LLM knows all these things. Yeah, this is simply not possible for one human to know all these things. Yes, but LLMs can. Yes, it has an enormous amount of knowledge. Yes, it has an enormous amount of knowledge, but it is not a person. Okay, so do not treat it as a person. Yes, like it has a lot of knowledge. Yes, but if you ask one plus two, it some LLMs can get it wrong. Yes, so LLMs can make mistakes, the type of which knowledgeable humans do not. Uh, but on the other hand, LLMs have so much knowledge that one person cannot have that much amount of knowledge. Yes. So you should uh, you should be very precise with LLM for people who are familiar with coding. Yes. When you write code, okay, you have to be very precise. Yeah, otherwise your code will not compile, it will not run, and so on. It's the same thing for LLMs. Yeah, you have to be very precise with LLM so that they give you the appropriate response. Okay, so that's one thing that I wanted to say about prompting. There's another thing that I want to say before we go to a demo, is the idea of retrieval augmented generation. Yes, so why do we need, first of all, this retrieval augmented generation? Yes, so as I told you, yeah, your LLM has been trained on a lot of data, all of internet, so it has a lot of knowledge. Yes, but there is new knowledge always coming up. Yeah, so for example, your LLM was maybe trained on all of the data till 2024. Yes, but then it has no knowledge that has come up in 2025. Yes, but you as a user, maybe you want to know what are the latest advancements in solar panel technology. And this advancement has happened in 2025. Now, LLM doesn't have data on this. I mean, maybe it was not trained on such data. Yeah, it was trained only on data pre 2024. Yeah, and meaning including 2024. Yes. So if the user submits such a query, yeah, is such a prompt, yeah. So user is asking some information on recent solar panel advancement. Yes. Then there is many LLMs have some sort of a retrieval system. Yeah, the retrieval system will fetch information. This could be information fetched from a variety of different places. Okay, from the web, meaning from the internet. Okay, or maybe the user himself provided a document on solar panel technology in 2025. Yeah, or there could be other sources also. Yes, but based on all these sources, this retrieval system fetches information and it puts the information in the what is called as the context window. Yeah, so remember I had said that context is something that you have asked the LLM till now, and the LLM responses till now together, okay, make the whole context of the conversation. Yeah. So this is the sort of the context of the conversation. Yeah. So within that context, some information from the retrieval system about current solar panels are extracted and they are put into the context. Okay, so these are, for example, some things that were extracted from some passage on maybe the internet or something. Okay, and this is added to the context. You don't see it. Okay, this is added behind the scenes. Okay, and then the LLM responds. Yes, so so this retrieval context, yeah, meaning this retrieved data, yeah, obtained from the retrieval system is added as a prompt to the LLM. Okay, you don't see this in the chat interface. Yes, this is all happening behind the scenes. And when the LLM responds, okay, then the LLM can pick up relevant information from this and respond appropriately. Yeah, so this one is responding for 2024 because I think this is a old graphics. Yes, but the LLM can respond using this new information that was fetched by a retrieval system and put into the context of the LLM. You don't see this explicitly, but it was put as a prompt to the LLM. Okay. And then the LLM is able to respond to your question. Okay. By getting appropriate information from this retrieved data. Okay. So that is what is called as retrieval augmented generation. Yeah, it's there is a retrieval part which retrieves information from either the web or some book or some PDF file that you upload or other things. Augmented because that information that is retrieved is used to augment the current context. Okay, it's given to the LLM. Okay, you don't see this part. Okay, you don't see the augmentation part. In fact, you don't even see the retrieval part many times. Okay, when you are for example chatting with ChatGPT. Yeah, all you see is the final generation. Yeah, the generation here relies on the retrieved information that was put into the context of the LLM. Okay, so this is called retrieval augmented generation or RAG. And this forms an important tool for LLMs to be able to serve information that it does not have. Yeah, because because the LLM, as you have seen, the amount of energy used to train LLMs is huge. It is not trained every day. Yeah, it's simply not possible. Yes. So LLM might have been trained maybe say January 2025. It only has information till 2024. If you ask information about any current event, okay, uh, it will have to use its retrieval system, which will might involve searching the web or things like that, and then fetching that information and putting it into the context of the current conversation that you're having with the LLM. Of course, this context is not explicitly visible to you. You don't see it, okay? But then putting it into that context, the LLM can now is aware of this information, and then it can answer the questions appropriately. Okay, uh, using the very current information that was fetched by the retrieval system. Okay. Okay, so that's all good. Yeah, there's a lot of things that goes into retrieval system. Yeah, the retrieval system is of course fetching information based on the prompt that you gave. It's not fetching arbitrary current information. Okay, so there's a lot of thing that goes into here, which I am not going to go into the details of. Then the thing that I'm going to do now is a demo of the Gemini system that is provided to by Rutgers. Okay, so let's get started with the Gemini demo. Yeah. So how do you access the Gemini offered by Google? So you can go to gemini.google.com. Yeah, that's fine. And you need to make sure that you're logged in with your Scarlet Mail ID. Yes. So here I am logged in with my Scarlet Mail ID. Okay. And if you do that, then you automatically have access to the Gemini, which is offered through Rutgers. Yes, that's important. The advantage of offering Gemini through Rutgers is your data is private. Yeah, meaning if you use some personal data, not personal data, maybe Rutgers data, you can use it here. Yes, Gemini will not use it to either train its model or to sell that data to somebody else. Yes, which is what a lot of these companies do. So that's why if you are doing any official work, it is very important that you use the Gemini that is offered through Rutgers, which means that you have to access Rutgers through this Rutgers login. Yeah. So that's one thing. Yes. Once you log in, yes, it typically shows you a screen like this, which is a screen where you will give some prompt. Okay. So let me just try some prompt. Let me just say, hello, how are you? This is not a like a great prompt. Yes. You see that I misspelled how, but that's fine. Okay. Some misspellings a little bit, these tools can tolerate. Okay. It gave me a decent enough response, maybe too much, maybe a little more than what I would have preferred, but that's fine. Yes. So, and if you click on these three bars at the top left, you can see your previous chats. Yeah, I have a lot of previous chats here, some of which was actually used to develop the material that I used to in the presentation. Okay. You can always do a new chat to start a new instance of this. Yes. And that is also great. Okay. The If you look at this tool, you can ask a lot of questions and so on. Okay. But there are somewhat different models that it offers. So if you click on this here, you see there is a fast model, the one that I'm using right now. It's a Gemini 3, yes. But it also has a thinking model. Yeah. So what is this thinking model? This thinking is the reasoning thing that I told you just now. Yeah. This is that model for which there has been this reasoning training done on it. Yes. And therefore, if you use this reasoning model, it can solve tasks that require reasoning. Okay. Better. Yeah. If I zoom in into this part a little bit, it also says that. Yeah. Thinking means it solves complex problems. Yes. It has a pro version, okay, which is an even better version of thinking, okay, which can think longer for solving advanced math and coding problems, okay. So there are different versions depending on what your task is. You should appropriately choose the right version, okay. So that's one thing. But if I just ask it some simple things, yeah, what is the changes changes in federal tax for 2026. Yeah. So let me just ask these changes. Okay. So I asked it a simple thing. Well, what are the changes for federal tax? Okay. And it provides me a nice list. Okay. Talking about some of the changes that have happened. Okay. And it pulls up all this information. Yes. So this is fine. It also is giving me sources. Yeah. So this is one other critical thing. We will come to this again in the next module a lot. But uh, because I asked it something about 2026, yes. So it interpreted this as seeking sort of current or future information, and therefore it searched the web to get this information. You see a link right next to these things. Yes, this is a link to different websites from which it is fetching this information. Yes, so if I click on this link, it takes me to this website from which I really got this from it, where it got this information. Yeah, I can click on this and it will also take me to the website. Yes. So, so that's important. Yes, that's very important because now you don't completely have to trust what it gives you. It is giving you these sources. You can also use these sources to uh, verify the information. Yes. Particularly, there might be a bad source sometimes. You know, for, I mean, there's a fake website or something. Yes, you don't want information from a fake website. Yes. So that's one good thing about Gemini, that it will give you the sources. Sometimes it will give you without even asking. Okay, like right here. Yes. Sometimes you might need to ask it explicitly to give the sources. Again, those are some prompting techniques we will look at next week. Yes, here we are just looking like briefly like looking at an overview of the tool itself. Yes, what all does it have? Yes, so I showed you the three kind of models that it provides to Rutgers. But there are a different number of tools that it provides. Yes, so here are different tools. One is guided learning, one is deep research, one is create images, and one is canvas. Yes. So, guided learning is a tool that is optimized for enabling learning on certain topics. Here, you might ask about certain topics. Okay, it uses a style of learning which is called as Socratic learning. Okay, so let me ask that itself to go. So, what is Socratic learning? Yes. So it will tell me that Socratic learning is this learning where things happen through a form of dialogues, yeah, like interactive, yeah. So where you ask questions, understand the students' current state of knowledge, and then revise and then ask questions based on that and clarify things and so on. Okay. I mean, it gave me a different kind of things. You can try this on your own, yes. Uh, but it can also tell you maybe some things about some topic that you want to know. Yeah, something in maybe accounting, a topic that you want to learn about. Okay, something maybe in information security that you want to learn about. It can give you a sort of good knowledge about these things. Okay, you can also ask it to cite the sources. Here it is automatically doing it. If it does not, you can ask it explicitly to do it. Okay, and it will give you the responses. Okay, so that's guided learning. Yes, but we saw there is a number of other tools here: deep research, create images. So create images is what, as the name suggests, this is a tool that can be used to create images. Okay, so you can ask in fact, this tool will be invoked even if you ask it to create image. So let me show you. Okay, so create an image showing um a tree and a lake with sky, with blue sky in the background. Okay, so I mean, this is just a sample query. Yes, but it's saying loading Nano Banana. So Nano Banana is actually the name of its image creating tool. Okay, and this is what it created. Okay, quite good. Yes, but you can ask it to also create fancy things. So create a pipeline pipeline image showing various training stages of LLM. Yes. So it can also create this. Okay. It takes a little bit time. Okay. It didn't create one. Okay. That's unfortunate. No, actually, I this one never went through. Yes. So, okay. I see. So it can create a variety of different images. Yes. Some one problem with this is often the text on the images is not really good. Okay. So it created a pipeline like this. Yes, it is actually showing a literal pipeline. Yes, I didn't really intend it to be that way, and that's because my prompt was not very precise. Yes. We will see next time. Yeah, like if you have a certain thing in mind, you have to very precisely state it so that the image generated or even the text response is what you expect. Yes. Okay, so this was about the image tool. Yes. uh, there is a deep research tool. Yes. And you can start this in a new chat. Okay, it is saying that you should start this in a new chat, and let me not do that right now, because I'll first show the other tool, which is Canvas. Yes. So Canvas is something where a sort of a Canvas window will open up on the side, and it will generate something which you can edit. Yes. So I will ask it to do something like this. So write a document about the privacy policy of Rutgers University. Yes. So let's see what it does. Okay. You see, it automatically understood that because I was in Canvas. Yes, it automatically opened this in a Canvas, which is like a window on the side. Yeah, I'm zooming in a little bit here. Yes, so that we can see the Canvas document properly. Okay, here is what it auto-filled. Okay, so it tells me about the university privacy policy and so on. And what I can also do is I can change this. Okay, so these policies are governed by both. Let me I just add about both the, yeah, university standard and federal laws. Yes. So I can edit this as however I want to. This is a document. And then from this, I can create some things. I can create an infographics. I could create a web page, a quiz, a variety of different things. I can print it. Yes, I should be able to share and export this. So I can export it to Docs. Docs here, I think, means Google Docs. Yes. So if I do that, Let me see what happens. Yeah, it gets exported into a Google Doc. Yeah, I can further edit it here as I want, or I can download this as a Microsoft Word doc. Yes. So, so that's all good. Yeah, you can write here, modify a few things like the font and so on. But you can edit it in the Google Doc also. Yes. So, so this is very useful where you want the Gemini to generate some content that you want actually in a document. Yeah. So here you will have this document directly in hand, and then you can edit it and so on. Yes. Uh, So that's the point of using Canvas. Yes. Now, suppose you want to know a little bit more about Canvas. Here, let me see how to close this. Here, close it here. I remove the Canvas tool. Okay, start a new chat. Okay, fine. I don't want Canvas again. Let me start a new chat. Okay, no problem. But I want to use the guided learning tool. So what I'm going to ask it to do is what features does the Canvas tool in Gemini have? Okay. And this will tell me a little bit about how you can do what all things you can do. Yeah, you can do quick editing, real-time refinement. You can turn reports from deep research, which we have not looked at, into sort of documents that you can export. Okay. This can be used for coding also. Yeah, that window that opened up was opened up for a document, but if you are asking for some code, it will open up like a code file. Okay, where you can edit the code and so on. Yes. And then there are a number of other things. Yes, I also don't know myself all the features here, but guided learning is the way to actually learn about the features yourself. Yes, and of course, many of these features you will um, learn as you use these tools. Okay. Okay, so let me close this guided learning thing. And the one last thing that is I wanted to show is deep research. Yes, so let's again, this one will open a new chat. So what do you use deep research for? So this is similar to deep research by ChatGPT. Okay, so GPT also has its deep research version. What it will do is this is particularly designed for searching on the web, collecting a lot of information, and generating a report that would have required you maybe from anywhere from half an hour to number of hours to do it yourself. Yes. So as an example, I want to say that summarize for me the current state of the auto industry in US. Okay. So because I'm using the deep research tool, it will do a lot of things in the background, yes, which you don't see here. It's taking some time, yes, but it generated a plan for me first. Okay, it will research some websites, it will analyze results, create a report. I will be ready in some minutes, yes. It will look up at things that are happening with respect to electric vehicles, tax credits and so on for electric vehicles and so on. So it told me what all it will do. Yes. And then you can ask it to do those things. Yes. So, and it also told me that this will take a few minutes. Yeah. It's not a simple thing because it has to do a lot of web search in the background to collect all this information and get them to you. Yes. So if you start it, it will take some time. Okay. And at the end, it will generate a report. Yeah, which you can. So it's still doing. Yeah, it's not completely done. Okay. So it's you are seeing some sort of it's thinking trace. Yeah, what is it thinking internally? Yeah, this is the reasoning trace. Yes, it doesn't always show you reasoning trace, but when you do deep research, it will tell you what it is doing. Okay, You can also look at the sources that it has been browsing. Okay, it has till now browsed 23 sources, but it might browse more if required. Okay, and there's a ton of things it will show, but at the end it will show a report. Okay, and that's very very useful. Yes, it compresses the work that might have taken a few hours for you down to few minutes. Yes, that's great. Yes, but this is something again we'll explore in the next module a little bit more, is that you have to be very careful about such kind of output. You have to verify things yourself. Yes, but the most critical thing is, even with you verifying things, you're going to save a lot of time for anything, not just deep research, but other aspects also. Uh, if doing a task takes you 30 minutes, okay, uh, and the LLM takes 1 minute for the task, you're saving 29 minutes. Yes, but that is not the right way to use LLMs. uh, you should let LLM take that 1 minute, but then you take 5 minutes after that to verify the output of the LLM. Yes. You still spend only 6 minutes, yes, way less than the 30 minutes you would have spent doing it yourself. Yes. So you saved still a lot of time, but that verification that you did after the LLM produced its output, that is super critical. That is super critical so that you are very sure that the LLM output is not a lie. Okay, it's also not hallucinating things. Okay, so those are things that are critical. Yeah, these are the things that we are going to look at extensively in the next module. So please wait for the next module to get into all these patterns of how to prompt the LLM and how to have a workflow uh, in order to use the LLM most effectively. Okay, thank you. So that's the end of this module.